A single grain of sugar contains enough energy to power a tiny robot for several seconds. This astonishing fact reveals the incredible hidden power within everyday ingredients. Cooking is far more than just following recipes. It's a dynamic chemical laboratory. Food science explores the molecular transformations that happen when we heat, chill, or mix. Understanding these processes unlocks a new appreciation for the meals we create. Why does bread rise or meat brown? The answers lie in chemistry. It's about understanding the fundamental reactions that turn raw ingredients into delicious food. Think of proteins as long chains, coiled up and ready to change. When you heat meat, these protein chains begin to unravel and rearrange themselves. This process, called denaturation, changes the texture and color of the meat.
The Maillard reaction is another star, creating those irresistible brown crusts and savory flavors.
It's a complex series of reactions between amino acids and sugars at high temperatures. But that's not the strangest part. It happens even at low temperatures over time.
Consider baking. Yeast, a living organism, consumes sugar and produces carbon dioxide gas.
This gas gets trapped by the gluten in flour, causing the dough to expand and rise. Imagine millions of tiny balloons inflating within your bread dough. Water also plays a crucial role, absorbing heat and transferring it efficiently. When water boils, it turns into steam, creating pressure that helps puff up pastries. And then something unexpected happened. The science explains caramelization too. Caramelization is the browning of sugars when heated, creating nutty, complex notes. It's distinct from the Maillard reaction, involving only sugars. Even simple things like chopping an onion involve chemistry, releasing pungent compounds. These compounds react with moisture in your eyes, creating sulfuric acid, which stings. But that's not the strangest part. There's a way to stop the tears. Adding salt to water can change its boiling point, a phenomenon called boiling point elevation. This means salty water needs to reach a slightly higher temperature to boil. Acids, like vinegar or lemon juice, can tenderize meat by breaking down tough protein fibers. They essentially pre-cook the meat on a molecular level. Emulsification is key to sauces like mayonnaise, blending oil and water which normally separate. Proteins and lecithins act as emulsifiers, creating stable bridges between the two liquids. Wait until you hear what comes next. The science of freezing is fascinating. As water freezes, ice crystals form, and their size depends on the freezing rate. Slow freezing creates large, damaging ice crystals that alter food texture. Rapid freezing creates smaller crystals, preserving quality better. Think of cooling chocolate. It involves carefully controlling temperature to achieve the perfect snap. Crystallization of cocoa butter dictates the chocolate's smooth texture and shine. Different fat crystal structures result in varying melting points and mouthfeel. This precision is why tempering chocolate is a vital chemical process. But that's not the strangest part. Fermentation is ancient alchemy. Microorganisms transform food, creating yogurt, cheese, and sourdough bread. Lactic acid bacteria convert sugars into lactic acid, preserving food and adding tang. Civilizations for millennia. The browning of fruits when cut, like apples, is an enzymatic reaction. Civilizations for millennia enzymes, called polyphenol oxidases, react with oxygen in the air. This creates melanins, the brown pigments you see forming on the surface. And then something unexpected happened. Even cooking methods have chemical effects. Pressure cooking speeds up reactions by increasing the boiling point of water significantly. Microwaves heat food by exciting water molecules, causing them to vibrate rapidly. This friction generates heat from within the food itself. The science of cooking is an ongoing discovery, revealing the magic in every bite. It transforms our understanding of the kitchen into a place of wonder. These chemical reactions are the unsung heroes of every delicious meal. Understanding them allows us to become better cooks and more mindful eaters. It transforms our understanding of the kitchen into a place of wonder. From the simplest ingredient to the most complex dish, chemistry is always present. The browning of toast, the fluffiness of a cake, the tang of yogurt, all are direct results of intricate molecular transformations happening constantly. This deep dive into food science reveals a universe of fascinating reactions. It shows how precise control over these reactions leads to culinary perfection. The science behind cooking is truly one of nature's most amazing phenomena. If you found this exploration of culinary chemistry enlightening, subscribe for more amazing insights. Let me know in the comments what food science fact surprises you the most. If you found this exploration of culinary chemistry enlightening, subscribe for more amazing insights. Let me know in the comments what food science fact surprises you the most.